Welcome back, and in our general transformation model, we just finished talking about the effects of C and D. So we still have to talk about A and B, and that's what this video is going to focus on. For E's, we're going to begin with A. Okay, A is a little bit easier to understand than B. Okay, so we're going to look at a different function. So we begin with our absolute value function, which if we look in a table, we know that that is, okay, this is absolute value of x, -2, -1, 0, 1, and 2. You might remember the table as 2, 1, 0, 1, 2. If you don't remember the table, well, you can compute it, but you should really know it. Okay, so now we want to describe the effect of the transformation 2 times f of x. Okay, now we need to maybe stop and think what this is saying. This is again saying take f of x, multiply it by 2. Order of operations, right? Okay, so then I'm going to make a new column here, and we call this 2 times y, or this is really 2 times absolute value of x. And so this is just going to be 4, because I multiply the y value by 2. 4, 2, 0, 2, 4. Okay, so then when I make a graph here, we have, okay, so 1, 2, 1, 2, 1, 2, 3, 4. Okay, so the base graph is going to look like so, and so I get a nice V shape going on. And now what I see with the transformed function is I have still 0, 0, but then I have 1, 2, -1, 2, -2, 4, and 2, 4. And now this time, we don't see the graph necessarily translating, right? There's no necessary translation, but what we end up doing is kind of multiplying the y value by 2 graphically, and what we end up doing is kind of, well, so I'm just going to use the language of y is multiplied. That's what we notice by 2, and so we'll give more formal language to this in a moment. But it kind of looks like the y value, like it went, like it is folding in on itself, like it's getting shorter, or it's getting longer vertically or shorter horizontally. Okay, if we look at -1/2 f of x, you might imagine what that could look like. And then I'm just kind of curious, what about negative f of x? So I am going to pull up Desmos here, and we're going to plot it in there. If you haven't used Desmos, amazing resource, and I can't stress it enough. So let's look at these in Desmos. So here we are in Desmos again. To access it, just go to desmos.com, and then on there there'll be a calculator button that you can hit. I just have it bookmarked. So here we go. So you can see the original function in red, and maybe I'll just switch that to black here quick so we can kind of match what we were doing in the other video, or in the other area. So there we are. And so now I want you to think about what y equals 1/2 f, or 1/2 square root, or absolute value of x would look like. You have the idea in mind? Let's see what it looks like. So it kind of went down closer to the axes. Okay, and then finally, for the negative, imagine what that's going to look like. Here we go. So that one is in purple, so it's down here. The other one, so again, if you want to see them 2 at a time, that is the negative absolute value of x, and then if you wanted to see the 1/2 absolute value of x, there you go. Okay, so anyway, we need to kind of move on and describe what's happening here. When we do this, we end up calling the a value a vertical. Most generally, it's going to be called a vertical scaling. Okay, and here what we're going to see is that if there's kind of 3 different cases. If the absolute value of a is greater than 1, we're going to see a stretch by a factor of a. And so a is just the number that you end up multiplying y by. And so we're going to say, so I should actually say, I need to insert, it's going to be a vertical stretch by a factor of a. Okay, if absolute value of A is between 0 and 1, then we call it a vertical shrink by factor A. And so this would look like a vertical compression towards the horizontal axis, and that's the case where we have the 1/2. We also have this negative case to deal with, and so if we just say that A is going to be less than 0, we end up reflecting over the x-axis. Okay, so you could possibly have two transformations here. You could have a reflection and a scaling or a shrink, or a shrink or a stretch, or you could just have one of these. Okay. All right, B. Let's see here. So we have a new function. Okay, this one is, so we have x and y. We have -2, -1, 0, 1, and 2, and this y is going to be the cubing function, so this is going to be -8, -1, 0, 1, and 8. Okay, and now it says the effect of 2x, so this is b, right? B, we're saying b is 2 now. Okay, so now as you remember, horizontals are a little wonky. What we're going to do is now instead of x, we're going to replace it with 2x. So for example, to obtain this value, you're going to say 2x is equal to -2. Okay, well, I can do that math. -1, or -1. Okay, so -1. And then for the next one, okay, so for this next value, you say that 2x is equal to -1. And so then x is equal to -1/2. And so let's see, 0. Okay, 2x equals 0 is going to be 0. That's really boring. So moving on there. Next one here, 2x is equal to 1. And so then x is equal to 1/2. And so at this point, you might start to see the pattern. Maybe, maybe not. This one's going to be 1. So I'm going to leave this to Desmos to draw it because it can do a much better job than I can. But the idea, at least from a rough sketch point of view, is that if this is our base graph, what we will see is that because the x values, when we look at plotting the highlighted columns here, so this x and that y, what we end up seeing in the transform function is something like this. So it actually looks like it gets closer to the vertical axis. So closer to vertical axis. Okay, so let's see what that transformation ends up looking like, and then we'll also look at these in Desmos. So if we hop over to Desmos here quickly, I'm going to delete all these out, and I'm going to look at y is equal to x cubed. Okay, and then I want to look at y is equal to, and then now, instead of x, I have 2x cubed. So that's the one that we just did by table, and it does look like it kind of squished towards the vertical axis. Okay, the next one that we need to look at was f of x over 2. So now I'm going to replace y equals, and then instead of x, I have x over 2, and I need to cube all that. Okay, so now if I look at just the base and this, I end up getting, yep, it looks like it kind of goes further away from the vertical axis. And then lastly, we ask the question about y is equal to the opposite of x cubed. And so then looking at this, oh, they look like mirror images across the vertical axis. And that is all true. So going back and kind of summarizing here, what we can say about B, we talk about B as a horizontal scaling. So that's kind of the language that we use for this. Horizontal scaling. And again, just as we did with verticals, there's kind of three cases here. We have if B is greater than 0, or sorry, yeah, if B is greater than 1 in absolute values, then it's a horizontal shrink by factor 1 over a. You'll notice that when we did the when we did the 2, we got closer to the vertical axis, and we're compressing horizontally. Imagine you're kind of squeezing it from the sides in, and or 1 over, this should be 1 over b, I'm sorry. Okay, if b in absolute values is between 0 and 1, then it's going to be a horizontal stretch by 1 over b. You notice that the factor here isn't b itself, it's the reciprocal. Okay, and then lastly, if b is less than 0, then it's a horizontal reflection over x-axis. And I think I may have misspoken earlier. It reflects over this should be, if it's vertical, it reflects over the y-axis. Okay, nope, that was right. I have it wrong now. That's x-axis and this is y-axis. Yeah, because we reflect, it's a reflection horizontally. Okay, and so here, this little part here, that is just kind of summarizing all of our work with scalings now. So a little bit longer video, but I had to introduce you to Desmos and all the magic that is Desmos. So if you need a copy of this down, please do. Next video, we've learned about A, B, C, and D rather, and now we need to apply them in order.